Hello. So today we have a panel on ZK and blockchains, which is a pretty big topic. So we'll try to drill in a little bit on that. I'm Jason Martin, CEO and co-founder of Zconduit, and I'll let the other panelists introduce themselves.
Hey everyone, my name's Yi. I'm one of the co-founders of Axiom.
Hey everyone, I'm Zach. I'm the CEO and co-founder of Aztec. We are a privacy-first layer 2 for Ethereum.
I'm Jordi Bellina. I'm the technical lead at Polygon ZKVM.
Great. So there's the Telegram anonymous chat is open. So if you want to throw questions, feel free. But maybe we'll start with a question from Brian Gu. He would like to know if rollups, coprocessors, and bridges are all secretly the same thing, or might eventually become the same thing.
I'm not sure if it's the same thing, because at least the functionality is different, but it's true that they share a lot of pieces, all of them. At the end, I mean, you can proving a chain, you can prove it because you are building the chain, or you prove a chain because you want to prove it on another chain. But at the end, you are proving the chain. So, so that's why it's so similar, and that's why it's so common. And yes, they definitely share a lot.
Yeah, I'd say they're all the same until somebody gets hurt and has their funds stolen.
Could you elaborate on that a little bit?
Well, they all can be used to provide similar functionalities, but with widely differing security properties.
Yeah, but for example, I mean, in a breach, in general, you need to prove the consensus mechanism. In the case of a rollup, you don't have to. I mean, this is it.
I mean, bridge doesn't have to either. You know, the bridge could just be, trust me, bro. You know, I'm good.
I'm talking a real bridge,
I'm
man.
good.
I think the key distinguishing factor is how you handle the state. I think in a rollup, you sort of commit to your state within a single commitment that the rollup is in charge of managing on L1. In a coprocessor, you explicitly don't do that. It doesn't hold any state. And I do think that we're going to see new designs that almost intermediate between these two. I think there are some, maybe private rollups have state that's in more of a UTXO type model, even in a rollup context. And I think that's because of the asynchrony of using ZK to manage every operation. So I do think that we'll see the lines blur going forward, and it's to be determined whether the blurring is good or bad.
Also, the bridges, they have a higher constraint, because in general, first is invented the network or the blockchain, and then you want to do the bridge for that blockchain. So you don't have, I mean, you have the full constraint. You don't have any flexibility to change the chain to adapt it to the bridge. In the case of the rollup, I mean, if you are building a type 1 rollup, you are very constrained. But if you have a 2 rollup, you have certain margin to modify or to change some pieces so that they get better adapted to the ZK tech in there. So that's, I would say, this just to mention some of the differences between the different projects or between the different usage of the zero-knowledge key.
I think one other trade-off to mention is a trade-off between handling synchrony and how diverse your computation can be. I think in a rollup, you're still running some type of blockchain VM because you want to allow synchronous composition on top of the state. In something like a coprocessor or a bridge, it's fundamentally async, and so you have room to put in kind of wacky stuff. I mean, things like machine learning, arbitrarily large can go in, things like arbitrary cryptography could go in, and you can imagine things that would fundamentally be impossible to gas meter in a rollup.
Yeah, well, in the rollups, there are different architectures. You can do it also very much async. Actually, this is quite a common pattern. This splitting the sequencing and the proving. So sequencing is the sync part. I mean, you are just building the network in the sync part, and then you can do asynchronously the proving part. this is the model that we are using, but many other rollups are using. And well, this has some advantages of this way. The first thing is that if you are sequencing in layer 1 and you get the data availability in layer 1, you get finality really fast because it's already sequenced. And then you prove later, maybe for exits or for things, it can be delayed a little bit more. But different models, different concepts, but yeah.
So that brings me to the next question, which is about infrastructure. So does the infrastructure required for these different objects, is it basically the same infrastructure? And how important is infrastructure in terms of the business defensibility of what you're doing? Like, do you need to own that infrastructure, or does the whatever it is rollup exist in some broader sense, even if it's not on your sequencer?
When you say infrastructure, are you thinking about servers and the quantity of computations
Servers, like
that you are?
Things that are plugged into a
bunch
wall
of servers,
somewhere.
bunch of computation. This technology is about computing and optimizing these computations. That's the topic. I mean,
Like, does it matter who pays the AWS bill? That's another way to think about it.
What the?
Does it matter who pays the AWS bill?
It's a huge bill. Even for example, when you are developing these things and you need to test things, and the bill for each developer, there is a special budget for each developer to have the servers. You can try to do things in the laptop and you just try to simplify, but at some point you need to prove the things in real things. And yeah, it's important. The cool thing here is that these costs are improving a lot, so every time is cheaper to do this. And that means that the costs, so the cost that the end user is paying, it's becoming very low. So the repercussion of the cost of the proving system, for example, in a rollup, actually is not the main. It's not the main cost. Actually, it's a little cost compared to other costs like the data availability and for example, the proving the proof on chain or other costs that are behind that. So yeah, it's a huge cost. It's about computation, but it's getting lower, and it's not that much on rollups applications.
Yeah. Sorry, let's just going back to the question. So are there different infrastructure requirements for bridges, rollups, and coprocessors? Those three architectures, protocols, they have fundamentally different user stories and different users. So yeah, the infrastructure is different. So for a ZK coprocessor, you probably don't need a decentralized network to provide the proving infrastructure. The idea is, I imagine, you can correct me on this, like the trust requirements are relatively minimal. Maybe you want some guarantees around censorship resistance, maybe. Both for bridges and for rollups, you're going to need for rollups, you're going to need some kind of decentralized infrastructure for sequencing transactions and proving blocks. And you have the same kind of blockchain trilemma and trust trade-offs as a layer 1 in that regard. So when it comes to infrastructure problems like C Ethereum, C Solana, C Bitcoin, they're all the same issues mostly, just adding in ZK. And for bridges, well, what do we mean by bridges? Because most bridges are just multi-sigs at the moment, so there isn't really any infrastructure to speak of. And if you want a bridge with strong consensus, strong finality that uses zero-knowledge proofs, well, that's basically just a smart contract in 2 different rollups on different networks. So the infrastructure, you can inherit the infrastructure of the underlying layer 2.
Here, let me disagree a little bit here. Well, I essentially agree, but in the rollup, if we split the sequencer and the prover, Of course, decentralizing the sequencer is very important. The sequencer is actually the one that can do things different and that has the power to include or not include transactions, or has a lot of power. So this piece is very necessary.
Yeah, and the prover is untrusted, and you have fewer requirements to decentralize. I agree on that.
Yeah, exactly. So the prover cannot do much. I mean, they either proof or not. If assuming that the proof is that the proving system is correct and so on.
You need redundancy. That's all. You need the ability if you because market forces will always generally trend towards a winner-takes-all environment for proving, because the faster you make the proof, the more efficient your proving infrastructure is, the more likely you are to make proofs on time.
Yeah,
so you just need redundancy. So if you get a scenario where you have a single prover, that prover goes offline. The network incentives mean another prover will spin up relatively quickly.
Look, in our case right now, we are having the idea is that at this point we have a kind of a centralized prover, so you have the right to centralize a prover. But the thing is that if the prover does not
you have
generate,
a centralized sequencer at the moment, don't you?
yeah, but the centralized sequencer is more important. I mean, it's more important. I think it's a real debate. But the prover. The idea is, so we are generating the proof, and if we are not, so if we in some time, I mean, it's a specific time, maybe if in 1 day, no proofs are generated, that means that, or so if the network delays the proof respect to the sequence of the state is delayed more than a day or whatever timing, then anybody can generate the proof. And there is some incentive. I mean, there is some tokens that anybody can generate that. Could you consider that a decentralized prover? There is this timing. I understand that there is this timing, and you can play that.
No, you can't. Let's be honest. I mean, semantically maybe, but practically no.
Let me frame that a little bit in terms of a question that just came in, which is, do you expect to see a rise of proof marketplaces, proof markets, decentralized markets, or infrastructure companies that just do proofs and don't have front ends? So each of you have a front end, right? Would you ever use such a thing or allow such a thing to enter into your stack?
Venture capitalists certainly think that's going to happen. If you look at how many are being funded, and they have a point. I do think that, like, I don't want to build a proving network and proving infrastructure. Like that's if you know, it's kind of it's not the core strength of Aztec, and I doubt it's the core strength of any of our tech stacks. If you can outsource that to third parties and you have an efficient marketplace, it seems like a natural business model. It's a niche that can be optimized. So yeah, I don't see why that won't be the future.
I think there's a couple trade-offs to consider. So one is there's a natural trade-off between decentralization and developer velocity and flexibility. So one thing to consider is for the co-processing use case, often the proofs are not run on a single prover. It's more of a distributed system. You really want to be coordinating couple machines or even fleets of machines to do synchronized proving and later recursive aggregation. And so that sort of thing I think is much harder to have a robust marketplace for. And even as proof costs go down, I expect it to be fundamentally, the notion of decentralization will be different than for something like a rollup where you want really hard censorship resistance guarantees. Here we're asking more for liveness than censorship resistance.
I'm curious, why would it be hard to provide a marketplace for that kind of service? We have fleets of provers. I mean, the way we're thinking about it is, a network posts a requirement to make a proof. They have you have the input data of the proving system, and if a prover offers volunteers to provide that proof, they have to post a bond of some kind of financial value they will lose if they don't fulfill certain latency requirements, and then basically how they make that proof, whether they have coordinated fleets of independent machines or something else, that's kind of an implementation detail, at least for the proven question.
I think that's a challenge. I think in reality, it's not quite an implementation detail, at least not with the current sets of proof systems we're dealing with. Just to give an example, if you want to do large-scale folding, the proof backend is quite complex. And I actually think this is one of the biggest downsides of folding. And I think the technology right now, I think, is pretty immature for me to feel like delegating proving to some third party that's just supposed to conform to the spec doesn't kind of degrade the security a little bit.
Yeah, I mean, now it's very early at the moment, but I can just see the incentives are aligning so strongly that in the future, we're probably going to consolidate it around proving systems that are more conformant with that type of infrastructure, just because it's so convenient to be able to outsource proving to third parties.
So yeah, that suggests another one of the core questions here, which is if everything is centralized and we're giving it all to a server, people start to think about privacy, and that was the old model of trust the intermediate, trust the middleman, trust the trusted third party. So is privacy still important in ZK? Does it still matter? What applications of privacy are the regulators going to allow us to do?
And let me here start, because I think if there is some project that's really leading the privacy in the space right now, this is Avtech. And I think if this, I mean, they are, I would say, 1 or 2 steps behind everybody else in the privacy side. And I think that the privacy is a fundamental value. Is something that maybe other rollups, it's not that we don't want or we don't forget, maybe we'll focus more in the scalability, in the other functionality, and but we'll need privacy, and privacy is a fundamental value. And I think here that Avtech, I think is leading this space, in this space, and I mean, a big fan of the work they are doing. So,
thank you very much, Jordi. Thank you. Yeah. Privacy is good.
It's necessary. I don't know if it is necessary.
Okay, question to the floor. Who here would be comfortable shouting out how much their yearly salary is? Any takers? No? So yeah, that's why salaries aren't paid on chain, and that can be extended to pretty much every kind of real world financial transaction system that we actually engage in. We have this implicit expectation of privacy that isn't met with current blockchain architectures, which massively restricts the potential for applications in the blockchain space. Right now, the value that is contained within every single cryptocurrency network is derived from either the value of the consensus token of that network or a dollar-backed stablecoin. For example, if Ethereum went to 0, every single token on Ethereum, the price would also go to 0 except USDC and maybe USDT. For blockchain to succeed, for it to actually become the transformational tool that we all envisioned back in the day, we need to bring real-world assets on chain, and that's not going to happen without privacy. It's not going to happen without being able to link identities of cryptocurrency accounts in a privacy-preserving way. So privacy is essential, I would say. And I can give a few use cases, maybe after, I don't want to monopolize time, but if you're curious. With regards to what will regulators allow, that's an interestingly phrased question. If anybody went to a regulator and was like, hey, could you write out a list of privacy-preserving applications on a blockchain that you're okay with? That list would be empty, because you're basically going to regulators and going, hey, how would you like less control and less ability to surveil your citizens' financial transactions? No one's going to go, yeah, I would like less power, please, thank you very much.
Well, what we've seen a lot is these central bank digital currencies proposing schemes like you have kind of a budget of privacy or dignity, or whatever you want to call it, of say $500 a month. You can spend that much privately, and the rest is tracked. So it's not quite zero. Right?
We're going to take a different approach. Now, one thing I want to make very clear about Aztec is that, as one of the fundamental values of Aztec, we need to provide security to people developing on Aztec, building applications, that they will be able to be compliant in whatever jurisdiction that they're hosted in. And we're sincere about that. We are going to be publishing several ways of enabling the ability to distinguish good and bad actors, the ability to prove your identity, prove that you are a good actor. But we are very clear about a few things. One of them is that we need Aztec, the network, to be completely permissionless. As in, the protocol itself is not going to be able to distinguish, it's not going to be able to determine who can and cannot transact on the network, who to censor. Because to do that, you need a controller. And then that's kind of completely undermines the entire value proposition of a distributed network because you're not removing any trust assumptions. The way I see it, when Aztec launches on day one, you will not be able to do anything with Aztec except deploy smart contracts to Aztec. It's very much like take Ethereum but remove the concept of Ethereum balances. That's Aztec on day one. And so, just like Ethereum, the protocol is completely neutral and does not make any kind of prejudiced judgments around like who can and can transact, what's good, what's bad. I think it's very important that every distributed decentralized network also applies that same philosophy. I don't think that's inconsistent with protecting users, but they are going to be different paradigms that will require a lot of education, debate, conversation before we can settle on standards.
One important thing here to mention is that privacy is not free, and especially when we're talking about blockchains. I mean,
absolutely. Pay me, Jordi. Where's my money?
So that's,
sorry.
That's important to understand and to know, and it's not free for the user. It's not free from the development perspective. I mean, developing projects, developing an application that's privacy by design, by default. I mean, that's privacy in mind is not. I mean, it has not the same cost. Actually, it's much more expensive, much more difficult. Sometimes even considered impossible.
A little bit more expensive.
Yeah, well, I mean, I hope.
We'll see.
But but at the same time, I think it's important here we cannot forget privacy in the space. So we tend to think in other values. I understand that some events that happen, here Tornado Cash and all this stuff, that doesn't help. I mean, this gives some especially for big companies and for big corporations. I mean, it's like, they get afraid. I mean, there is they get this afraidness about privacy of course for you not, because it's your core value. I mean, you need to be facing that. But I would say here is a matter of the space. It's a matter of the technology that we are building. I mean, if we don't take privacy in account, I think was mentioned that, but we will not be able to bring this technology to mainstream.
I think one thing to say is that a lot of the applications of privacy we've talked about so far are about financial privacy. And I think that's what draws a lot of the scrutiny of regulators. And I actually think one thing that can help establish ZK and sort of flexible privacy as a legitimate way to even satisfy regulatory concerns is to have other use cases for privacy that don't immediately trigger, regulator flags around different sort of, capital control restrictions or various sanctions lists. I think uses of privacy in games, one of the most direct applications of privacy is you can't play poker if you can see your opponent's hand. Or even uses of privacy for protecting intellectual property. Maybe there's pieces of information like private weights or risk models that service providers don't want to show on chain, but they want to demonstrate they're using some model or allocation rule. And I think implementing more of these can help establish ZK as a tool that regulators believe can actually have guarantees that have anything to do with regulations. I think if you read, for example, KYC today, by the letter of the law, cryptographic proofs have nothing to do with KYC. You're supposed to really have the exact identity of everyone who's transacting. And I don't think there's necessarily a mathematical or cryptographic reason for that, but it's mostly an education problem with how these laws were actually written.
Well, yes, they're written before that kind of a concept was possible. I agree with you in principle, although I don't think we're going to rehabilitate the reputation of blockchain by enabling private ZK poker.
Yeah, I don't know about poker.
Certainly, yes. What is privacy? I think privacy is identity, as in the sum of all of your commoditizable data, the information that a company, a government, a service will want because they can make some money out of you. That sum, the set of all that information is really very much how governments, companies, perhaps people will view you and understand you as a person. And being able to prove aspects about your identity privately, I think, is it's existentially important. And to give some like non-financial use cases, something that's simple like WebAuth. Wouldn't it be nice if instead of having an Ethereum public-private key, your identity was a smart contract that validated a WebAuth signing process? So you could sign in, you could transact on Web3 with your Google account or with your Apple account. That would be extremely convenient for most types of transactions. The trust model is completely fine. You don't mind, a Google account securing your identity. And it's also not workable without privacy, because then, well, it's a bit of a problem if all of your cryptocurrency transactions are indelibly linked to a specific Google ID, and that's completely transparent. So that's one example of where privacy is very useful. Another one is when it comes to compliance, regulation, I genuinely think that with distributed programmable private settlements layers, you can provide stronger security guarantees than the existing compliance solutions in the real world. For example, normally when high notional transactions occur, the transaction is executed and then post-fact compliance and KYC information is supplied to prove that the actors were all acting and were all good, they're all good guys, no, they're not on sanctions lists. And it's not very effective because often by the time issues are raised or flagged, like that transaction disappeared in the ether and the proceeds have gone, they've gone outside the jurisdiction in question that matters. With ZK, you can do preemptive checks. So you can prove, like a transaction can only happen by definition if the transaction sender, for example, has signed has a US or UK passport that signed an authorization signature. You can only submit a transaction. You can have contracts where a transaction is only valid if the counterparties proved that they possess, for example, KYC tokens provided by some KYC provider. Being able to do these kinds of checks, apply checks and balances programmatically and preemptively, I think is a game changer, and I suspect that once this becomes widely understood and recognized, it's going to open up an enormous amount of financial innovation with regards to TradFi moving to Web3 type platforms that, at least in the early days, will be largely independent of the existing kind of more decentralized Web3 flows.
Here, understanding zero knowledge not as a tool for hiding information, but a tool for selective disclosing the information. This is the big value of this technology. We can do queries on our data, so we can, this is an example that I like a lot. So imagine that when you are hiring an insurance, they just need a bit of information. Is if you apply or don't apply for that insurance on there. You just need one bit of information. But in order to prove that bit, in order to give this information, that's a bit, you need to maybe give all your historical medical data to this insurance company. And this is something that zero knowledge is, it's perfect, suitable for that. So it's not about hiding anything. You want to prove that you can apply for that insurance. But you don't want to reveal much more information that can be used for whatever. Any business, the banks. Problem of the banks is that they're doing the work for the governments, for following things and stuff. The banks, they don't care about your name. They don't care about your where you live. They care if you have enough money so that you can get a credit, if you have enough collateral, what transactions are you going to do? But they are asking for...
I think you're quite trusting. I think they care because they sell that data as well.
They care what?
They care because they sell that data as well. Side hustle.
Yeah, well, I'm talking about what they're saying. But that's why it's important. You see that. That's why it's important, this technology. I think that this technology applied in the right way can give more security without having to sacrifice the privacy. And this is,
Are you concerned about this sort of the slippery slope here, where once we start proving properties about ourselves, we'll be asked to prove those properties all the time? right? So in order to get on the bus or to buy a piece of paper, I need to show that I'm not on a sanctions list, or I need to know that, you can imagine a world where that becomes extremely invasive if we make it too easy for people to prove properties about themselves. You're sort of back to the situation of total surveillance.
I think that, generally I'm not a fan of the slippery slope narrative in general. I think it's a bit of a logical fallacy because it's ignoring the fact that we are how much do existing real world transaction flows align with the society's values? As in, do we live in a society that is very happy with the concept of everybody having to prove statements about themselves in order to be given permission to participate in certain actions or privileges? I don't believe so, because I do think that at some threshold level that starts to severely violate the concept of individual sovereign rights. And we will see. It is certainly a risk, but I think people may surprise you in that. Establishing a social norm that everyone has to ask for permission from authority to participate in public life. I feel like that's a red line for most people.
I do think the cultural view on this depends on where you are. I think different cultures actually have very different views on privacy even. I think you said earlier maybe people don't want to shell out their salaries. I do think there are countries where your salary is a matter of public record. So that's definitely a cultural statement.
Fair enough.
Yeah, and probably also an age and generations thing. I mean, I see people, especially young people, just, they have a public life. They share everything that happens, they need to be published in some, in some social media somewhere. So the education about privacy probably is not in the best moments in the social media. I think that after the scandals of Facebook and so on, maybe we recover a little bit this sense of privacy, but I think that nobody doubt that a certain amount of privacy is required and is a value that all humans sooner or later we need.
Sure, so let's get even broader. So, Vitalik has gone on record a few times saying that he thinks that ZK will be as important or more important to technology than blockchain over the next 10 years. Do you agree? Probably you do, because of your choice of profession, but, and if so, what's the vector by which that happens? How does that unfold?
Yeah, ZK is just a fad, No. I agree, albeit I'm very biased. I can try and give some examples of how this will unfold. I'm going to be paraphrasing a lot of narratives from Brian from OX Park, so I'm going to attribute him to these ideas. But I feel like I very much see ZK through the lens of privacy. Obviously, there's scaling as well, but I'm going to give the privacy take. Where having if you have privacy, you have identity on chain, which means that you can start to meaningfully digitize real-world assets and create a global settlements layer of the world's assets. And that, by itself, would be quite transformational in terms of liberating a lot of very stuck illiquid assets. It'll enable people living in developing countries or areas with very weak rules of law to be able to access high-quality financial services that do not require trust of local institutions. But this is barely scratching the surface, as in the idea of having a privacy-preserving distributed settlements layer is, the way I see it, it's a way of planting a seed whose roots will sink deep into the earth. Because what was going to happen at lower abstraction layers is the concept of composability, arbitrary composability between all types of digital software and services. What do I mean by this? I'm thinking about using ZK as a form of data transformation pipelines. So let's say I'm creating an app, and I want that app to get some information from a user's Facebook profile. And the users are okay with this. Well, how do I do that? Well, I can get the user to send an API request to Facebook, and they can then send it back to me as a JSON blob, but then, well, I'm not going to trust that they do that correctly. By that I mean I'm not going to trust their software. And also that data is going to be formatted in, according to like Facebook's weird custom API. It's not going to be in the format that my app needs. And ZK can solve this, because what could happen instead is that you provide, the user requests the information from Facebook. They construct a proof of knowledge that proves that they've done this correctly. So you use like TLS certificates, DNS signatures, and you then format the data according to my application's API. And then again, in ZK, prove that's correct. And what you've done is you just basically created a little pipeline between Facebook's information silo, which is proprietary, closed source, third party, and my information silo. And you can take that kind of that simple basic primitive, that building block, and you can apply it across like pretty much every single kind of information network and transaction network that exists today. And only only very few of those types of transactions are going to bubble up until into being posted on actual on settlement layers like Ethereum or like Aztec, because they'll need to contain significant value. But I think you're going to see a kind of a very radical transformation in how different application servers can talk to each other, and a substantial erosion of the ability of Web 2 services to create like sealed information modes where they can then leverage that information for commercial advantage and network effects.
I'm gonna maybe give a vision more from the cryptography perspective. Cryptography is one of the oldest science of humans. Probably from the humans exist, they need cryptography somehow. I mean, in the Middle Ages, there were cryptography and ideas. Okay, we had a very important revolution, the moment of the invention. I mean, cryptography was about getting a message, encrypting and decrypting, and that's this is that historical message, I guess. Symmetric cryptography, that's what we understand that. There was a huge revolution, I think it was in the 60s or 70s, when the concept of public-private key was invented. This changes a lot. I mean, this is what allows the cryptography to be used in a network, especially in the internet, was very, very fundamental for also the concept of signing. And there was a revolution in the cryptography systems. But with the zero knowledge, we get another revolution here, is that for the first time, we have programmable cryptography. I mean, at least, so it's the first time that engineers starts not using cryptography, but also somehow designing cryptography, which is a little scary, just all been said, okay? But actually, it's real. I mean, we can prove whatever we want. I mean, we have here a degree of freedom. Until now, I mean, if you were using a signature, I mean, you were using closed, black box, clear systems that were designed by mathematicians, and you better don't touch that on there. So here, I think that we're entering a new epoch, and I know, well, I mean, Aztec is gonna, it's gonna rebate me that, but I think that I'm going to say the good things on that. You're going to say the bad. But the good things is that for the first time, we have engineers. And this opened the spectrum, engineers that are going to take the cryptography as a science. And they are going to build, create new applications and start getting deep in the cryptography. So I think this transformation, I mean, the ZK, especially the programmable part of the ZK, will explode. I mean, cryptography will not be, let's say, a sub-science inside the mathematical, theoretical way, maybe with some applications in the real place. It's something that it will be more engineers, more people building things with that. Of course, this is scary, But I think this is a good opportunity also for the cryptography to evolve and to evolve fast and to have systems where the cryptography is used in real applications.
Why would I say bad things about that?
I mean, you're a cryptographer. You should be scared about engineers touching the cryptography.
Well, kind of. I would say I'm an engineer that started doing cryptography, and I did enough of it that people started accepting me as a cryptographer. But I don't know, around these parts we roll around crypto, and we live with the consequences. I think like one of the core mandates of Aztec is opening up cryptography to engineers. You know, hiding away the moon math, the intricate details, and exposing an abstraction layer where you can apply simple heuristics that are intuitive to an engineer in order to write safe, secure code that compiles to ZK circuits. I think that is existentially important for this, to bring this technology into the mainstream. So no, I agree with everything you said.
Well, just say that in today's days, most of the teams that are working cryptography, they have a mixed team. I mean, it's important to have some pure cryptographers, people that understand the math part, the demonstration part, the internals of all this.
So let me back up. Yeah, if you're rolling crypto, yeah, that's important. But if you're like, take Noir, for example. I'm going to just shill a bit of Aztec tech right now. www.noirlang.org. It's a great piece of tech. It's a programming language that it's like Circom. You can write in a Rust-like syntax, and it compiles down to zero-knowledge circuits. You don't need to be a cryptographer to use Noir. In fact, we're failing if you need to be a cryptographer to use Noir. The idea is that you can be a complete novice to the space. You know, like you can be scared and intimidated by cryptography. That's fine because you don't have to learn it. You just have to learn a simple set of heuristics in our documentation around different paradigms, like what's expensive, what's not expensive, what can you do, what can you not do. So that's what I meant by you don't have to be a cryptographer to use ZK. You do to develop it.
Every time I agree that the tools every time are going to be better, and they are going to abstract this dangerous part on that. I mean, I don't want to do a comparison between Circom and Noir. I think they are even different for the
Noir's
places.
better funded.
But I mean, for example, in Circom, it's true that, for example, one of the big nightmares, as one of the things that have been working more, is about this. It's about simplifying and giving guarantees to the user about the soundness. So Circom is very flexible. You can do whatever you want, but if you don't use it in the right way, you are going to create some soundness problems, at least, for sure.
Yeah, but I mean, Circom was really the trailblazer, which was the first. Well, actually, I'm not sure which came first, Circom or Socrates, but those two languages were really attempting to do this something very radical, which was this create an abstraction for programmers to write ZK, and and I see this space, design space, iterating. So we want to get Noir to a place where really you can't write you can write buggy code, but you can't write under constrained code. The idea is that kind of like the only way that your program can not function correctly is if the program logic you've actually coded does not actually map to what you wanted, the functionality you wanted, which is a bit different to under constrained issues.
Yeah, but that's right now in Circom, for example, if you're following certain rules, we can give you these warranties too, but you need to follow these rules.
Yeah,
I mean, it's a little bit more lower level.
Same with Noir, but the rules are pretty. You don't want to follow those rules because the rules suck.
The bad news is that, of course, Circom and Noir on this circuit-specific language will have, we'll have some applications for some specific circuits, but I think that most of the ZK is going to be developed in Rust or in C++.
Noir's not a circuit-specific language. What do you mean by that?
No, I mean that, would say that most of the circuits in the future, and we are seeing, for example, with these emulations, I mean, we are building an EVM. EVM is a processor itself. RISC-0 is building RISC-V. We are a little bit far from that, I agree, but I think that this is the...
Oh, no, I'm going to... Sorry, bit of friendly spice here. You say most transparent ZK systems use VMs. How many privacy-preserving systems that are approved client-side use VMs?
Not yet.
Yeah.
But
And not for a long
my
time.
bet is that, I don't know, maybe in 1 year, 2 years, 3 years, we will start seeing more applications that use general purpose ZK processors.
For privacy, I actually disagree because I feel like you're trading a huge amount of accessibility there, because these ZK processors, if you're adding a virtual machine into your tech stack, so instead of writing circuits, instead of programming the circuits, you program as to opcodes that get interpreted in a virtual machine circuit, you're greatly increasing your proving time, but that's not that much of a concern. Like, I think that's fine. We can improve that with hardware, with web GPU. The big problem is memory consumption. You have very little memory on physical devices, particularly if you want to access markets in the developing world, where you have even weaker hardware that's generations old. You're talking about less than a gigabyte of RAM to make your proofs, and yeah, you can write a virtual machine ZK architecture, but it's going to be cutting out a lot of users.
It's more a technical detail, but in general, you can always buy. So you can do the things with less memory by doing more, by adding more processor on there. So you can always.
I don't have more processors. I'm talking about client-side proving.
Yeah, but figure out. I mean, I think that. We don't here the question is, it's going to be longer sooner or later, but I think this will
sooner or later, but don't hold your breath.
Sooner or later, or if you want, which are the complexities of these circuits. And I agree that right now we are not there yet, but if you compare now in where we were 3 years ago, my bet is that in 3 years, we will be very close.
I think this illustrates a counterpoint, I think, to the engineer-cryptographer dichotomy. As someone who's actually probably self-described as neither, I think that one thing that the recent evolutions in ZK has brought is just a lot of new people who are interested in learning the space with a much higher incentive. I think when I studied cryptography in college, frankly, it was kind of a backwater subject. Like, it was not super popular. There was kind of a well-defined set of things you could do. You could quickly learn the algorithms to do that set of things. And, it was tough to get too much more excited. And so I think one thing that this new wave of cryptography has brought is people who really can learn, I think the full cryptography and also the full engineering. And so I think that the dichotomy, I think maybe it's a false one. And to the point of improving the performance, I do think once you show people that it would be very valuable to improve the performance, then many people are going to try quite hard. And frankly, that's what's driven a lot of the progress in the last 3 years in the space.
Yeah, the question is if we are getting to the limits or not. And this is, I think, the discussion with. So you can push the things, but at the end you need to do multiplications, and you need memory. Okay, and I think this is the argument of.
But we're far from the limits. The limit is committing to the input and the output. We're very far away from that.
Here, the other question is, for example, if this computation is delegable. I mean, here there is a lot of work to do.
Okay, yeah, well, that's a thorny issue, because in theory, yes. In practice, oh boy, you're opening up a security can of worms. So when it comes to let's talk about like making SNARK proofs. Let's say I've got a big SNARK circuit I want to prove, and it has lots of secret information I don't want to leak. But I can't make it client-side because it's big, it's chunky. I need like half a terabyte memory. Well, you can use Shamir's secret sharing to do it. So the idea is that you take all of your witness statements for your SNARK, all your witness polynomials, and you split them up into shares. So instead of having instead of a secret share representing a point, your secret shares represent polynomials. And then you can send each share off to a third party, and they can construct a SNARK proof. And they don't have enough information to reconstruct your witnesses because they just have one share. But because SNARK constructions are very the relations that you're checking are all very linear or linearizable, you can then, once you have the proofs that have been made over each share, you can then take them back as a user and you can combine them to create a valid proof. This is, whilst it works technically, I personally am very uncomfortable with it becoming a primitive that's widely used because it massively opens up possibilities of collusion between those third parties receiving the shares. And if my intuition and hunch about ZK is right, that it's going to be used as a backbone for an enormous amount of services and products where a lot of secrets are going to be contained within these circuits, it seems like a really bad, risky pattern to start following using delegated MPC-based computations. So it can be done, but I'm very bearish on applying that at scale.
Yeah, you can always have your server running in your home. I mean, there is.
Yeah.
I just want to.
Just like the internet, everyone will run their own server. Sorry, I'm sorry, I'm being very acidic.
I'm running my validator in my home, so why not?
Well, you are, but you're the co-founder of
okay,
Polygon Zero.
I'm not a good example. But it's if privacy is that important, why not? I mean, that's just putting. I know that's a little bit future, and I agree that this is not asking everybody to run a server in his home is not the easiest thing to do. But if you want to decentralize if you want to decentralize the system, you want to decentralize the world, I think that thinking in running that each individual or each family in each home, there is some computational power, some server in there. It's not a bad. I mean, it's something that we should consider somehow.
Unfortunately, I just don't think human nature is going to just gels with that vision. Because, okay, let's phrase this another way. Who are Aztec's competitors? It's not you. It's not you. Our competitors are existing Web 2 protocols, companies, financial services that are providing the same services to users that we want applications on Aztec to provide. Basically, it's Web 3 versus Web 2. It's Web 3 versus TradFi. And so people are, by definition, comfortable with the existing set of financial services and identity services in the real world because they're being used. And so if the alternative that is, okay, well, you can do this autonomously, via Web3, and you get more control of your data, but you need to run your own server, I think most people will go, actually, I'm just fine with the status quo, thank you very much.
So maybe the cell phone of 5 years from now is the server of today.
Maybe, but generally servers need to be on all the time.
I mean, your cell phone.
Is on all the time.
Maybe.
We have just a few minutes left. I want to throw out one more question. So we've talked a little bit about kind of the win condition for ZK and blockchains and how we might get there. So let me ask you, what's the lose condition? What's the risk factor, either for this industry, if you're right and ZK is just a fad, or for society if we take things in the wrong direction? People were very idealistic about sort of citizen journalism, and I think that didn't end up as well as we had hoped. So, where might we go that we don't want to go with this technology?
I think whenever we use ZK, especially, or crypto as well, we impose an additional cost. And I think we need to make sure we're actually solving a problem for users that can justify that cost. I think in recent years, obviously, a lot of blockchain has been, driven by speculation. So actually, users are kind of getting paid anytime they perform any action. And I think that masks a little bit the fact that they're paying significant real-world infrastructure costs to actually run Ethereum nodes, to generate proofs. And as a space, I think the most important thing is to actually solve problems that people would care about, even if they didn't know about ZK or about blockchains. And I really think the failure mode is that we end up tackling problems that just aren't significant enough to justify the level of infrastructure being devoted to them. Or maybe the marginal value of the more decentralized solution over a super centralized solution is not sufficient.
To expand on that, I think there is quite an explicit trade that one is making when using this kind of these Web3-based services, which is that we are trading increased infrastructure costs for decreased process costs. So what do I mean by that? Let's say, imagine I want to make a relatively large bank transfer. So let's say, I don't know, maybe you've found some skeletons in my closet and you're blackmailing me, and I'm going to send you $2,000 to shut you up.
Only on Aztec.
Only on Aztec. No, through a traditional banking system. What do I have to do? Well, I can't do that via my internet banking app because it's over the threshold, so I've got to call my bank. They're going to put me on hold for about, 15, 30 minutes. That's a big waste of time, waste of potential. And then I've got to talk to someone on the other end. So there's a worker, somebody sitting in a call center that's going to be taking my call. I'm going to have to run through a bunch of checks to say, to make sure that I know what I'm doing, that I'm not being scammed, that I'm not being blackmailed by ye. And then once I've finished with that process, they're going to enter some information in their system, in their information silo, which is going to initiate the transaction. But then your bank is going to be doing the same thing on the other side in your back office. So that transaction is going to go through, and there's probably going to be somebody in the back office going, oh, that's a large transaction. I need to check this, blah, 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 blah. Like, think about the man hours that's wasted on that flow. Now, we just kind of accept it because that's the way things are done. So with the Web3 system, yeah, you're adding additional infrastructure costs, but compared to the people costs of the processes you can eliminate, it's substantially better in a large number of use cases.
I think the thing I worry about there is that it puts us in a position to be short social progress. Like, you're describing that the wire system is very inefficient today, and having sent some wires, I agree. But what if it gets better? Then the marginal value we're providing drops a lot. Like, for example, in the US, I think blockchain payments are just less compelling because Venmo is pretty good. Yeah. And FedWire was introduced recently, and it just dropped interbank transfer times in the US quite a bit. I think it's close to real time now.
Yeah. Well, let me articulate, if you've got a bit of time, I know we're running out, more clearly what I mean. Because you're right that that it's like people-based processes can get better, but I still think that the trade-off is still apparent. So the idea of what I'm really saying is that, why does this annoying process happen between interbank settlements? Is because these banks have carved out these vertically integrated information silos that they are then using to extract commercial advantage. They use that information to make favorable trades, to increase their amount of leverage, and they want to protect that information, which means that there is a frictional cost to get information from from my bank silo to your bank silo. That's not an accident or an inefficiency. It's by design, because of the very nature of the system that's been set up. And those are the kinds of costs that aren't going to go away with innovation, because it's not a technical constraint. It's an artificially placed constraint to extract value, and Web3 provides an alternative route that gets rid of it. Could I be super annoying and steal 20 seconds to talk about loose conditions? I think there's several of them. One of them is basically that privacy services start to take off, but then our societies basically have a discourse where everyone says effectively, actually, I don't care about privacy. I don't have anything to hide, therefore I have nothing to fear, and I would much prefer a central bank digital currency that's completely surveilled and audited. That would be the lose condition. Another one is basically in 10 years' time, if the fundamental value within cryptocurrency networks is still derived from the consensus token, and you don't have out-of-band, off-chain assets being traded on those networks. I would say that would be a lose condition. I think if all of the ZK proving infrastructure tech companies basically all go bankrupt and we don't have any, that's probably a lose condition because it implies that there is no demand for ZK. Those are a few in my head.
Or is ZK proving it's free?
That'd be nice. Verify says yes. Optimistic ZK.
Yeah, I think that we will not see. So the first real applications, the first societies that will use massively the blockchain space, the crypto space, the technology, the tools that we are building here, they are not going to be Europe, US. This advanced. These societies, of course, they have a lot of problems. We know what the central bank is doing. Even the governments, there is a lot of corruption, whatever you want. But if you compare, they are not that bad. But if you go to some, let's say, some more underdeveloped countries, where they don't even have the system is absolutely corrupt. They don't even able to build a currency that takes longer than 2-3 years because they are just print whatever they want. I think that these places, these societies, this is where the real value of the blockchain is. And I have the feeling that we will see massively using blockchains in Africa, in Central America, in parts of Asia, that in US, in Europe, we'll end up using. But who's going to lead the deployment, the usage, the real usage, who will really take real value of the values, is where in societies where this central power is not able to succeed. And here we have huge value in the space. So we have the huge value is here. So I don't know, but I think I'm betting that these places is where we will see before real usage of the technology.
Thank you. I think we should wrap it up there. So this is the last programming for today, and we start again tomorrow at 10. Thank you very much.